Welcome to our fifth meeting or fifth session, where we continue our journey to become a certified security engineer. Okay, welcome to our fifth meeting or fifth session to become a certified security engineer here. So let's pick up where we left off last time. Quite a lot of topics planned for today, so let's not hesitate. Let's not start already. I think last time we finished with the secret manager, so I shared the best practices there with you. The next service that was on the list is a VPC service control swap, right? So I guess you might have already learned about it, but this is something you will not see on your own, because this is something that is being set up on the org level as well. So let me first unpack it a little bit for you, so you can think about it as a kind of a firewall setup for your data services, right? I think we have even a slide that compares the firewall to VPC service control. So what is it about? It is about you not really controlling some networking aspects of some services, right? So for example, if you are creating a BigQuery dataset or a cloud storage bucket or any managed data service, this is where you don't get to say where it lands. You don't choose a VPC, you don't choose a subnet, you don't assign a CIDR rate. You don't even have to have a VPC in place to create a bucket, right? So from that perspective, you don't have any control over the IP spaces. And if that's the case, you cannot really rely on firewall rules, right? You can only say, hey, this person can access this bucket just because he or she has privileges, has IAM roles to the bucket, right? But you can say that perspective, you don't manage data service of some services control. So what is it about? It is about you not really controlling some networking aspects of some services, right? So for example, if you are creating a BigQuery dataset or a cloud storage bucket or any managed data service, this is where you don't get to say where it lands. You don't choose a VPC, you don't choose a subnet, you don't assign a CIDR rate. You don't even have to have a VPC in place to create a bucket, right? So from that perspective, you don't have any control over the IP spaces. And if that's the case, you cannot really rely on firewall rules, right? You can only say, hey, this person can access this bucket just because he or she has privileges, has IAM roles to the bucket, right? But you cannot say that that person can or cannot access the bucket based on where they are trying to access it from, right? What's the source? And you cannot also say that the information from this bucket can be copied over to this location, but cannot be copied to a different location, right? So this is where those VPC service controls come into play. As you can see, if you go to them, VPC service controls, it's just another service, but it requires you really to switch to the organization scope, right? And if we do it, we actually have a possibility to create so-called perimeters. Before we move on, let me just mention that there is a dry run mode, just like with Cloud Armor, just like with some other services. Just because if you block some kind of a traffic, well, you can block some valid traffic, to be honest, right? This is why Google gives you dry run mode to test it out. So let's have a look at the creation of the perimeter. So basically, this is where you are deciding if this should be a regular one or a perimeter breach. You should be also aware of what those are, right? Basically, bridges between two different perimeters that you have created, right? But basically, this is where you need to choose what resources do you want to protect, right? So I guess there is also a slide like showing us two projects that are within a perimeter, right? So they chose two projects, right? So we can do the same. We can say, I want to add two of my projects to a perimeter alternative. You can work with VPC networks, right? So instead of adding projects, you can add VPC networks, but that's like a side thing. The main thing is to add projects. And then you want to say which services within that project you want to protect, right? So you can obviously add all of those services, all GCP APIs, or you can say, maybe in that project, I have some specific storage buckets with sensitive data. This is the API that I want to protect, right? And then you decide on some other things like those access levels we talked about when we covered identity IAP, right? You have ingress and egress policies, right? So you add rules. This is really, really similar to firewalls from that perspective, right? And in the end, you end up with such a thing where you have a perimeter with some protected resources, and you are saying that if there is a threat of an exfiltration, right? Because this is what VPC service controls are about, like a rogue admin, someone with privileges, maybe someone who like stole your service account key that maybe you have uploaded to a code repository or something like that, right? And they have IAM permissions to access your data, and they're trying to do it from outside, right? From outside of the perimeter, from the internet, from wherever. They can't do it even though they have IAM privileges. And the same goes with the outbound traffic or egress traffic. If someone is trying to fetch the data, right, from your BigQuery dataset, for example, and copy it somewhere outside of the perimeter, this is also not possible, right? So think of VPC service controls as an additional mechanism in parallel to IAM permissions and a kind of firewall rules thing for your data services. Whenever you get a question about data exfiltration risks, this is where you should think about VPC service controls. Yeah, there is one more service that's really applicable for data exfiltration. Who can tell me what that is? What would you think about? Another GCP service that will I'm sorry. I think I lost you or you lost me. I hope it's good now. IAP, I would say DLP, right? I'm not sure if you went through DLP, right? GCP DLP, now it's still called data loss prevention, but it's now also called sensitive data protection. I think there was a lab that you went through or you will go through when it comes to this one. This is also about saying, okay, if data that is sensitive is here and it's being moved outside, then VPC service controls can like protect or can block that movement, and DLP will not like stop that movement, but it will make sure that when your sensitive data moves somewhere outside, then it is being somehow anonymized, changed, and the sensitive data is thrown away, right? So this is how you might think about it. Okay, I don't want to focus on those questions, but there are a couple about VPC service controls. The next topic is DNSSEC, right? So I think that, well, basically DNS or cloud DNS is a pretty big topic, and I don't want to spend time on it too much, and I don't even think that it's super relevant for the exam, meaning you might get a question about DNS, like we have a question, well, no, you don't, but you might get a question where you would need to understand things like DNS peering, forwarding zones, etc. And the best practices, like, all the GCP resources should be resolved within GCP, and then you should make a kind of a setup where your on-premises resources names are resolved in on-premises DNS. And then you should make practices like, all the GCP resources should be resolved within GCP. And then you should make a kind of a setup where your on-premises resources names are resolved in on-premises DNS servers, right? So there is quite a complex way to set it all up. You might get asked about it, but it is, from my perspective, it is a ton of knowledge. Like you would spend like 2-3 hours probably in order to understand it well, and you might get one question about it. So this is where I'm saying, if you're not super interested into DNS, feel free not to spend too much time on it. Just focus on DNSSEC, which is a kind of a feature of DNS, right? Make sure what that is. Make sure to go through the overview here, the documentation that is there. And also make sure to follow this one, right? Migrate or transfer DNSSEC enabled zone. So basically, if you go to DNS, right? If you go to Cloud DNS, let's switch to a project there, and let's go to Cloud DNS, then handling DNSSEC is like trivial, meaning you create a zone and then you choose if you want to switch it off or on, right? But also there is that transfer thing, okay? That's what you need to understand. And the second part you need to understand when it comes to DNSSEC is how to migrate those zones, right? So the story is that you already have a zone somewhere outside of Cloud DNS, and that DNS zone is DNSSEC enabled. Now, how do you make it happen that it gets transferred to Cloud DNS? And let's switch to a migrate or transfer DNSSEC enabled zone. So basically, if you go to DNS, right? If you go to Cloud DNS, let's switch to a project there, and let's go to Cloud DNS, then handling DNSSEC is like trivial, meaning you create a zone and then you choose if you want to switch it off or on, right? But also there is that transfer thing, okay? That's what you need to understand. And if you want to switch it off or on, right? DNSSEC is like trivial, meaning you create a zone and then you choose if you want to switch it off or on, right? But also there is that like trivial, meaning you create a zone and then you choose if you want to switch it off or on, right? But also there is that transfer thing, okay? That's and then you choose Cloud DNS. If you go to DNS, right? If you go to Cloud DNS, let's switch to a project there, and let's go to Cloud DNS, then handling DNSSEC is like trivial. Meaning you create a zone and then you choose if you want to switch it off or on, right? But also there is that transfer thing. Okay, that's what you need to understand. And the second part you need to understand when it comes to DNSSEC is how to migrate those zones, right? So the story is that you already have a zone somewhere outside of Cloud DNS, and that DNS zone is DNSSEC enabled. Now, how do you make it happen that it gets transferred to Cloud DNS? And it's still DNSSEC enabled, right? So there is a procedure there. Basically, you have to first deactivate. DNSSEC at your register at the very beginning, then you transfer, right? And hence this transfer setting here, and then you enable DNSSEC in Cloud DNS, and then enable it or activate again at your register, right? So quite a specific process that you need to understand, you need to know in order to handle those DNSSEC questions also, right? So a question there from your end, if Google Cloud expose any API for an automated response? I'm not really sure if I understand that question, to be honest. So please try to be more specific, maybe email me with that, because I'm not sure if I understand it. Okay, the next topic that's, well, that is, I'm not even sure if that's super important. Like, we will spend like probably 20 minutes on that, and it's good for you to understand GKE, Kubernetes. In the exam guide, there are points about securing images, about binary authorization, about vulnerability scanning, etc., etc. So it's good to understand the security aspect of GKE, but I don't think that you have to focus it very, very much. Basically, Google loves Kubernetes, loves GKE, but looking at the exam guide itself, it doesn't show that you have to be experts here. So just follow me here. We will cover like 10 plus different Kubernetes-specific security aspects. I will try to explain them in the easiest way I can. With that knowledge, I think you will be good from that perspective, even if you are not experts with Kubernetes with GKE, right? So let's have a look at those. So what are the Kubernetes-specific security best practices? When it comes to the cluster, let's go to the cluster creation mode, right? So let's go to clusters. Let's click create a cluster, and in order to see everything very well, let's switch to a standard one, right? Okay. Click Cloud Shell. Yeah, it's closed. So whenever you are creating your infrastructure for your GKE cluster, right, then you have to make a number of decisions. The first one would be what kind of image would be used, right? You can use Ubuntu, you can use Windows, both with container DS, container runtime. What Google is saying, just use the default one, which is container optimized operating system, right? This is Chromium-based operating system. They have added some security features to those, right? Like lockdown firewall, limited user access, disabled root login, etc. So they are like more secure than the others, I would say, right? The second thing is just to create a private cluster. So this is where you would go to networking, and you have a choice between a public and private cluster. It's just as easy like with VMs. Like public cluster means that your worker nodes will have external IPs when you speak. Private cluster, your worker nodes will have private IPs only, right? And obviously this is the best practice. On top, IPs. When you speak private cluster, it's easy like with VMs. Like public cluster means that your worker nodes will have external IPs. When you speak private cluster, your worker nodes will have private IPs only, right? And obviously this is the best practice. On top of that, every GKE cluster has something called control plane, right? It's kind of a brain of Kubernetes. And And the decision between public and private cluster, it's only about those worker nodes, right? Another decision is about the control plane. Basically, the control plane is managed by Google, right? You don't see that VM. Normally, when you create a Kubernetes cluster, this is a separate VM for you. With GKE, it's like a managed service, right? The control plane is a managed service, so you don't even see. So in parallel to saying, I want my cluster to be private, you can decide if you want to access your control plane using its external address or not. And on top of that, you can add so-called authorized networks, right? Remember that with GKE, you always talk to the control plane. You don't talk to the worker nodes directly. Like the control plane is the middle, like the man in the middle, right? So from that perspective, you can also increase the security by saying only some specific IPs, right, can connect to that control plane of my GKE cluster. So you can add one or more authorized networks there, and this is also a best practice, right? Following on that, if we have a private cluster, then this cluster would have the the same potential issues that a VM or a managed instance group would have without it. External IPs. What are those issues? Well, the first one, or those challenges, right? The first one is that it cannot go outside to the internet to fetch something. Out external IPs. What are those issues? Well, the first one, or those challenges, right? The first one is that it cannot go outside to the internet to fetch something. The solution for that, for a VM, is what? A cloud NAT. The same solution applies to GKE, right? Your GKE cluster nodes will be able to fetch something from the internet if you set up cloud NAT, right? Now, if those nodes need to communicate with some GCP APIs, they can't because they don't have external IPs, so they don't know how to go to those APIs, right? To BigQuery or do anything else. The solution, again, is the same like for a VM. Enable private Google access. Right? So go to the subnet, enable it for the subnet where the nodes are in, and those nodes. Nodes will be able to consume them, right? So pretty similar things that you need to do just like for a normal VM, right? Another best practice from security perspective, just stay more or less up to date with GKE, with Kubernetes version, meaning that Kubernetes is a very dynamic application. A lot of vulnerabilities there probably, right, that are being regularly patched, etc. Google will always patch the control plane for you, but your decision is to choose how your worker nodes are being patched. You can make a decision to say, hey, I want some kind of a static GKE version, and I will, or Kubernetes version, and I will patch it on my own, but it's not a recommendation. Basically, just sign up to one of those channels, and Google will make sure that you are up to date and your whole cluster is more secure. Okay. What else do we have? Shielded nodes. That's something that actually we need to switch to VMs for a second because I don't think we covered shielded nodes until now. Right. So before we move on, let's have a look at the VM. So you might have noticed, right, that when you created a VM, you have a couple of settings there in the security section, right? Security, and what do we have here? We have something called shielded VM, and that shielded VM is actually an umbrella for those three settings, right? Secure boot, VPPM, and integrity. Monitoring. For the exam, you have to know which one does what's the difference between those, and so on and so forth, right? How do you make it happen? Well, probably you might have already learned about it, but if you haven't, just follow the documentation, and let me paste the link to that documentation there. And if you spend like 10 minutes to go through that relatively short documentation, you will understand it well enough for the exam. So basically, shielded VM is a protection against boot or kernel level malware or rootkits, right? And Google does a lot of things that basically make sure that no one messes up with your boot sequence and with the binaries that are being used to boot your VMs, right? If something changes, right, that may mean that someone has just hijacked your VM, and Google might detect it, and your VM might not start, but instead you will get some information in the log saying, hey, please check it out because we have noticed that this and that happened, right? So just understand those three concepts there. And yeah, the basic idea is to enable those, right? Now the question goes to you. How do you make sure that anyone creating a VM will follow those, right? That will be okay with those settings, that will not turn all those settings. How do you make it happen? Alistair has a very valid question in the meantime. Do we need to have all three options checked to have a shielded VM? Well, shielded VM is just a name for all of those, right? So it's like, I don't know, it's a kind of a nomenclature thing. The best practice is just to get all of them turned on. Just like Nitin says, org policy is there to enforce that all VMs follow or have those turned on. This one is turned off by default, just because it is about, as you can see, ensuring that the system runs only authentic software by verifying digital signature of all boot components and halting the boot process in the signature verification phase. So Google is saying this is a best practice to turn it on, but since some customers may be using their own operating system images, and they might have used some of their own boot components, right, which do not have that digital signature, right, because that signature is, the firmware is signed and verified using Google CA, right? So if you're using some custom boot sequence and custom operating system images, you might run into trouble if you are using secure boot. This is why Google is playing it like not very safe, but rather very convenient, like in many default settings, right? They're saying, okay, let's not risk that our customers will not be able to boot the VM from start because they will get mad. They will not know what's going on. So let's just turn it off by default. But the practice or the best practice is to like enable all of those. And yeah, there is an org policy to do just that, right? So switching back to our GKE setup, this is just the same, right? Just like with for a VM, you can enable shielded nodes for your GKE cluster, so nothing weird about it. I don't want to go too deep here, but basically with Kubernetes, there is a storage type called secret. This storage type is not perfect because it is not really encrypted per se, but this is only base 64 encoded, so not super secure approach, I would say. And this is why just remember that when you need to inject some secrets, some information, some passwords, something like that to your Kubernetes workloads, to your containers, to your pods, just use Secret Manager, right? That's the end of the story. To your Kubernetes workloads, so your containers, to your pods, just use Secret Manager. Information, some passwords, something like that to your Kubernetes workloads, to your containers, to your pods, just use Secret Manager, right? That's the end of the story. I don't want to go much further than that with that. And the last thing before we move on to today's deck is privileges, right? So if we go to IAM, then it's perfectly enough to use IAM to grant privileges to your GKE clusters, right? Just because there are some specific roles, and if you click grant access, if you write Kubernetes, then you will see a lot of roles like Google Kubernetes Engine admin, cluster viewer. Maybe someone needs to use the maybe someone is a developer and they are just using the cluster to deploy their workloads, then they don't, you will see a lot of roles like Google Kubernetes Engine admin, cluster viewer. Maybe someone needs to use the, maybe someone is a developer and they are just using the cluster to deploy their workloads, then they don't need to manage the cluster, but they will be Kubernetes Engine developers, right? So this is enough, right? You don't have to go deeper than that, but the best, you will see a lot, right? So if we go to IAM, then it's perfectly enough to use IAM to grant privileges to your GKE clusters, right? Just because there are some specific roles, and if you click grant access, if you write Kubernetes, then you will see a lot of roles like Google Kubernetes Engine admin, cluster viewer. Maybe someone needs to use the, maybe someone is a developer and they are just using the cluster to deploy their workloads, then they don't need to manage the cluster, but they will be Kubernetes Engine developers, right? So this is enough, right? You don't have to go deeper than that. But the best practice from security perspective with Kubernetes is to use namespace. What is a name? Namespace. A namespace is a kind of a isolation component, an object. within Kubernetes where you say, I have a single cluster, but I have like 5 teams working on that cluster, and each team should only see their resources. Each team should only see some specific, physical resources of the cluster, and they also, where you say, is a namespace. A namespace is a kind of a isolation component, an object within Kubernetes where you say, I have a single cluster, but I have like 5 teams working on that cluster, and each team should only see their resources. Each team should only see some specific, physical resources of the cluster, and they also should not see or influence anything that the other teams are doing within the cluster, right? So this is a kind of a, I don't know, a project within GCP. You can say something like that, right? And a thing that isolates workloads within your cluster. So from that perspective, you can also go a little bit deeper. And the best practice is not to assign privileges based on IAM only, because with IAM, you can only say, hey, this person is a developer for the whole cluster. You cannot say that this person will see only a specific namespace, right? This is not a possibility with IAM. So Google is saying that the best practice is to use IAM on the cluster level, right, for granting privileges to someone who will manage the cluster itself, and then use RBAC. RBAC is just role-based access control, right? This is a kind of an IAM for Kubernetes, I would say. So Google is saying use IAM on cluster level, and then use RBAC, use this for granting privileges to someone who will manage the cluster itself, and then use RBAC. RBAC is just role-based access control, right? This is a kind of an IAM for Kubernetes, I would say. So Google is saying use IAM on cluster level, and then use RBAC, use this Kubernetes specific privilege thing for on namespace level, in order to make it happen that your developers see their namespaces only, and they don't get to influence the namespaces of the others, right? That's the idea behind RBAC, okay? Okay, moving on. Still a couple of topics, I guess, connected with Kubernetes. So let's still spend a couple of minutes on that, and then we will move to other topics. Service accounts also pretty similar, like for a VM, like when you are creating a Kubernetes cluster, then you would choose which service account is being used to run those worker nodes. And by default, it's the same service account like for a normal VM. So compute engine default service account is being used. So the best practice is what? Is not to use it, right? Just use the custom one, create a custom role that contains all those 6 roles. And I think you went through a lab where some of you were struggling with those, right? I think it wasn't super clear that all of those roles were supposed to be there. But basically, this is where you should create a custom service account for your GKE workloads. And the same goes with service account keys. Remember, on the first or second session of ours, we said service account keys are the last resort. They shouldn't be used because they pose a security risk. So something should be used instead. What should be used instead for GKE? Something called workload identity, right? And I don't want to go too deep here because I don't think it makes sense for that exam. But if you are running Kubernetes workloads, then you should definitely dive deeper. Like you should understand workload identity. And on high level, it's very similar to what we already covered with workload identity federation, right? Where we said instead of creating the service account key and moving it to that workload, right? We are doing something, some kind of a setup, token-based, IAM-based here, that will allow us not to use service account keys at all, right? So meeting asks, can we change with service account to assign to cluster? Yes, obviously that's the best practice, right? You will change the service account, but if you pay attention, it is not even per cluster. It is per node pool, right? So you can have a cluster with multiple node pools, right? You can add one more or more node pools, and each node pool can actually be running with a different service account. So this is also an option for you to say that you have a cluster, there will be different workloads deployed there, and maybe each of the workloads have different requirements from privilege perspective, and they will be running under different service accounts, right? So yeah, definitely you can. Okay, and basically the last thing, which is called GKE sandbox. So just remember the use case. The use case is sometimes you are creating your own workloads. You are writing your own applications, microservices, and you deploy them to a GKE cluster. Then you kind of have all the knowledge about it. You trust those images, right? Because you have built them faster. Then sometimes you are creating your own workloads. You are writing your own applications, microservices, and you deploy them to a GKE cluster. Then you can. Okay, and basically the last thing, which is called GKE sandbox. So just remember the use case. The use case is sometimes you are creating your own workloads. You are writing your own applications, microservices, and you deploy them to a GKE cluster. Then you kind of have all the knowledge about it. You trust those images, right? Because you have built them, you have full insights into them. All is perfect. But sometimes it's not that great, meaning you might have just downloaded an image from a third party, right? Some vendor, exposed their application, their software via giving you a Docker image, a quite a popular setup where you just deploy images of someone else's to your clusters. And this is where GKE Sandbox can be used. It's also a setting per node pool, right? So as you can see, let us find it. I always struggle with finding it, probably there in the security. Yes, you can enable Sandbox with gvisor, and this basically enables that setup. That gvisor is basically an open source software there being used, right? But it is now called GKE Sandbox here in Google. You can enable it, and you will turn on additional security layer, which will make sure that those containers built with the images that you don't trust fully, they will not be able to go out to the VM level to find out some specific sensitive information about the whole VM, etc. Right? So it's about constraining them a little bit, making sure they don't exceed the thing that they should see, right? That's the idea when it comes to GKE Sandbox. And be aware that this cannot be done on the default pool, right? So if you go to the default pool, as you can see, it is grayed out. Sandbox with gvisor is not available on the default node pool. So you can enable it only on additional nodes. And just really, really lastly, Google tries to actively look into how you are using your GKE clusters, meaning there are a lot of moving parts, there are a lot of decisions there, and Google is trying to actively scan through your infrastructure and through your workloads to tell you how secure your cluster is, if there are any vulnerabilities. In the libraries or binaries that you are using, are there any issues with the infrastructure itself? Maybe your pods are running with privileged containers. That was your decision that you made, maybe unconsciously. So there are a lot of insights here that will make sure that will allow you to increase the security posture of your GKE clusters, right? So that's how you might think about it. Let's try to answer just one question about GKE. So this is actually about a company with a cluster that was exposed to the public internet and had recently recovered from an attack, right? And now we want to basically analyze the details, analyze the logs, etc. So how do we do it? How do we approach the question? What answers might we eliminate in the first place? What do we start with? What do we eliminate? Eliminate DLC, great. This is mostly because it suggests that you view the logs in the local GKE cluster, right? So you might know that it is not really necessary because just like for all the resources, all the services within GCP, GKE logs will be just forwarded to cloud logging, right? And telemetry will be forwarded to cloud monitoring. By default, you don't have to log into the cluster, to the worker nodes, anywhere to see those. So this is not really cost or time effective. So now we're left with A or D. So which one would that be? What do you think? The question asks us to analyze, right? What does it tell you from storage perspective? Analysis. What type of storage would be optimal for analyzing some events, things, etc. Exactly. That's AD. Why? Because we have BigQuery there. Exactly. Okay. Let's move forward to another topic, unless there are any questions about Kubernetes still. The other one is still quite a big one. Or maybe before we move on, let's just have a look at a couple of questions from this week's quiz, right? So let's try to answer a couple of those. And by the way, those quizzes are always shared with you when we share the decks every week. So we have some sensitive data in cloud storage, and we need to address it somehow. What do you think about this one? Which do we eliminate? Which do we choose? Why? Okay, eliminate C and D. So it's eliminate A, C, and D. Okay. So what I would say is, what do we need? We want a key generated and stored in on-premises, right? What does it mean? That we should use KMS or we should follow customer supplied encryption keys, meaning here we go with CMAC, right? Here we go with CSEC. What do we go with? I think that the question suggests us to go with CSEC actually, right? Because if we want our key to be generated and stored in on-premises, that tells to me that this key shouldn't be stored in KMS, right? Because with CMAC, you can generate a key, but it is still stored in KMS. Maybe you can choose the external thing, right? So let's go to KMS, right? Because you are suggesting to go with KMS, with CMAC. So you would create a key, right? But this key can be stored either here within GCP, within KMS, or in external key manager. But remember that there are only 4 suppliers or integrations with 4 systems, with external systems. The question asks really about storing the key in on-premises. So from my perspective, it suggests that we should really use CSEC, right? Customer supplied encryption keys, where we have the full control over the key generation and storage, etc. Right? So this is where I would eliminate KMS, because the question asks about something more. If the question only asks about, well, managing the encryption keys, then I would be good with KMS, but it suggests us something more. Okay? So now the second decision, DEC or KEC, right? Do we manage? If we use CMAC, if we use CSEC, it doesn't really matter. If we take over the encryption, do we manage data encryption keys or do we manage key encryption keys? Like in other words, what are those? What are we really creating here in KMS? Are we creating a DEC or are we creating a KEC? Exactly, Nitin. We are only managing KECs, right? So please make sure to understand it. There is that envelope encryption, right? Envelope encryption in GCP, which basically says that your data, okay, is first, you work on the data, right? It can be on data on a persistent disk, on a BigQuery data set, it doesn't really matter. You work on data in GCP. This data is encrypted, or it is first chunked. Maybe you are working on a big disk, it is chunked into smaller pieces, and each piece is encrypted with a DEC, with a data encryption key. You have no control whatsoever of those DECs. So in other words, even if you manage encryption keys, you really don't control how the data is encrypted. But then that data and a DEC is stored somewhere, and the DEC itself is encrypted with a KEC. This is the green one, right? And this is the key encryption key that you really manage and store in KMS. So please remember that there are 2 levels there, and all you manage when you go to KMS, when you upload your keys, right? When you go to GCS bucket and you create a bucket, and somewhere there you say, hey, I want to where was it? I want to use my own encryption key, right? And to point to that encryption key. This is where you point to that KEC, to the green one, right? You never have influence over DECs. So please try to remember it, and this is why the answer is the last one, right? Okay. Yeah, DECs are automatically generated. This is a type of a question that is a pretty standard one for IIM. So let us have a look at this one. We either create a key. Okay, we have a couple of answers already. It's a B and a D. So we either create a keyring for all persistent disks here, right? Or we create a keyring per persistent disk. Remember that a keyring is actually a directory for your keys, right? So I don't see a reason, at least in that question, for us to create a keyring per disk. I would say that a single keyring for all disks would be enough, right? Just because it is like a bunch of disks that are somehow connected, right? And the question even says that the permissions to those keys must be managed in a grouped way. The permissions should be same for all keys. So I would even say that, yeah, the answer B makes more sense, right? A single keyring, right? We might have different keys for different disks, right? But then from IAM perspective, if the question asks us for the same permissions for all those keys, then it's enough if we manage those on keyring level, right? Technically, we can do something else, right? Because this is our keyring. This is where I can manage my permissions, right? It's here. But I can also go to keys within that keyring, and I can manage permissions on key level as well. It depends on business needs. Here we don't see that really, right? Exactly. So this is AB. Okay, let's move forward then. Let's have a look at the other topics that we still have. So the next one, quite a big one, is CI/CD security, and this is where you just need to be aware of many different things, because the attack vector is huge, right? Whenever you work on your codes in a codes repo, build that code, test it, deploy it here and there to test dev, prod, version that code, use some third-party binaries, use different third-party services to automate the CI/CD pipeline, and so on and so forth. There are a lot of stages, there are a lot of points where you can actually somehow get hacked and that are vulnerable again at different types of attacks, right? So what does Google say about it? Google likes to shift left, meaning prevent as soon as possible, as early as possible. This is why they have the service called Cloud Workstations. If we go to workstations, you will just see a service where you can provision some environments for your developers, right? So that may not be super important for you. It depends on how you manage it at the moment. If you have a lot of developers, do you have a consistent and streamlined way to manage their environment, right? Or does every developer has full authority, what they install on their laptops, what tooling they use, how they set it up, etc. If that's the case, this is also a threat, right? So Google is saying either manage it all in a consistent way on your own, or maybe use Cloud Workstations, which is a service where you can get those managed development environments with some built-in security, with web-based access to multiple code editors, and that may be okay for you, right? So that's the first service. But now let's try to focus on the whole pipeline, right? Let's imagine that we are writing software, and we need to collaborate on the code that we write, right, as a team. Now, where do we even store the code, right? Where would you store your application code that you are writing, that you are improving, that you are versioning? What would be the service that you would use for the repository of that code? Git, great. Something more cloud native or Google native. Google has something called source repositories, and actually this is a private Git repo, right? So the answer, Git what was perfect, right? Just be aware that Google has a service for that, right? It's called CSR, Cloud Source Repositories. It may be exchanged somewhere in the future, so be aware of that. But for the exam, it's CSR, where you either create a new Git repo, right, or you connect to something that you probably know and like, right? So you probably are experienced with, or your companies are using either GitHub or Bitbucket as those Git providers. So this is where you don't have to create a repo within GCP, but it's enough if you integrate, if you connect a GitHub repo with from CSR, right? So this is to give Google visibility into your code repository in order to have the ability to automate, right? So let's see what happens next, right? We are aligned that this would be our repository of the code. Now, what should happen then? After we are ready with the code, after we commit it, what should happen with the application code? What should you do next? What happens next in the pipeline? And what service is responsible for that? We have the code. Now, how do we move from the code to an application? Exactly, we build the code. So in order to build the code, what do we have? What service should be used? Jenkins, maybe, right? Or anything third party. But for the exam, please remember about Cloud Build. And this is where you can create triggers. Now, why we are talking about triggers? Because it is all about output. In order to build the code, how do we move from the code to an application? Exactly, we build the code. So in order to build the code, what do we have? What service should be used? Jenkins, maybe. Right? Or anything third party. But for the exam, please remember about Cloud Build. And this is where you can create triggers. Now, why we are talking about triggers? Because it is all about automation. If you automate things, then it somehow affects the security as well, because it is repeatable, you omit some human errors, etc. And with those Cloud Build triggers, you can say something like that. Here is my repo, right? And this is why we created the repo in CSR, or at least integrated that repo with from GitHub or Bitbucket, right? We are telling Cloud Build trigger, this is my repo, right? And please just automatically react on some events on that repo in CSR, or at least, and with those Cloud Build triggers, you can say something like that. Here is my repo, right? And this is why we created the repo in CSR, or at least integrated that repo with, from GitHub or Bitbucket, right? We are telling Cloud Build trigger, this is my repo, right? And please just automatically react on some events on that repo when someone pushes to a branch, right, etc. So if something happens, if someone commits the code in the repo, the trigger will automatically fire and will do something. What it will do? Well, it will build the code into an artifact. That's the primary thing. That cloud build is responsible for, right? But also, please try to remember that cloud build is much more than that, right? So you can define different steps, right? And building the code into an artifact can be one step out of many. Those other steps can be something like static code testing, some checks, security relevant checks as well, right? It can be deployment to a development environment and then testing something there, right? So just please remember that cloud build, it is called build, but it can do much more than just building a repository into an artifact, okay? Now what happens then? We have the code, now cloud build creates an artifact, right? Builds the code into a artifact. Maybe that would be a Docker container or anything else. Now, where do we store that, right? Because we know that we store code in source repositories, but where do we store the artifacts after the build has finished? GAR, okay, that stands probably for Google Artifact Repository, right? So let's go to Artifact Repositories. So that's another service, okay? In the past, it was called container registry. It was only about containers. Now you can create repositories there for different formats as well. Just be mindful about it. Now, how this one is applicable for security. This is applicable just because of this thing, right? Cloud builds will produce an artifact. Will upload each version of that artifact of that Docker container, for example, here to that repository. Now, as part of the CI/CD pipeline automation, you should also automate the vulnerability scanning. So, for example, my objects, my artifacts were not scanned at all, right? Now, the best practice would be to, well, you can manually scan them, right? Obviously, but you could actually automate it. So you could really automate the whole process. Like when a developer commits the code, that commit is triggering cloud builds to first build an artifact, perform some static code testing, upload the artifact here, and then the artifact is being automatically scanned against vulnerabilities. So you're probably aware that Google knows about those vulnerabilities out there, right? They see through, or they look throughout the internet, throughout different reports, etc., for all those vulnerabilities that are out there. They are constantly keeping that database up to date, and they can really scan through your artifacts, through your Docker container, and tell you, hey, this is a report. And that report contains, I don't know, 532 findings, and you have some critical ones, some high ones. Maybe you have a finding where you are using some outdated libraries, right? This is a high vulnerability. This is the link where you can get more info. It can result in this and that. You should do this and that in order to address it. For example, maybe you should use a newer binary, right? So this is how that report may look like. It can be a long one, but basically it can tell you how vulnerable is the artifact that you have just created. So this is really important from the exam perspective to understand that you can have that automatic scanning of your artifacts whenever they are built, right? Now, another thing that we need to understand, right? Another service, the last one actually that we will cover from CI/CD perspective, is called binary authorization, right? So until now we said, this is our code in CSR. Cloud builds takes that code and places the artifacts into artifact registry. Those artifacts can be automatically scanned, and then what? Well, maybe nothing, right? Like vulnerability scanning gives you a report, nothing more than that. You can act on that report, you can just ignore it. Right? So if you want to have something stronger, if you want to have a mechanism that is able to technically allow or deny some images to be deployed to your productive cluster, for example, this is where binary out allows to have something stronger. If you want to have a mechanism that is able to technically allow or deny some images to be deployed to your productive cluster, for example. example, this is where binary authorization comes into play, right? You can think of binary authorization as a kind of a gatekeeper. So what is it about? It is about first creating a GKE cluster, or I think it also works for Cloud Run, right? But basically, this is a setting where you might create a cluster and you might say, hey, this cluster will be binary authorization enabled, meaning it is not a cluster that just blindly accepts every image that is being deployed on that cluster, but the image that is about to be deployed there will go through a check, right? And that check will be aligned with the policy. So another policy that we need to create, right? And within that policy, I'm not going into details here because this is quite an advanced process there, but within that policy, we can define what security aspects we care about. For example, we can say, we only accept images that do not have critical vulnerabilities, right? So from that standpoint, we are creating a binary authorization policy that says, well, since that image was scanned for vulnerabilities, now I can make a decision that an image is trusted, say it is treated as a trusted image because it does not contain any vulnerabilities that are critical, or that image should not be published, right? Because it is considered untrusted because some critical vulnerabilities were found there, right? And this is where I define it within my policy, within binary authorization. And then when that image is about to be deployed to that GKE cluster, then the cluster checks, okay, if I'm binary authorization enabled, if not, it is deployed, no issues. But if it is binary authorization enabled, it checks that image against that policy, and then it decides either it's trusted, then it deploys it, right? No issue there. If not, if the image does not comply with some of the rules that you have created within that policy here, then it is considered untrusted. It will technically not even be deployed to that GKE cluster or to the Cloud Run service, and your developer will have to go back to the very beginning, actually, right? Because there will be an audit log saying, hey, this image was not okay with the policy. So you have to go to the beginning, you have to edit your code, address some of those findings, like maybe fix those vulnerabilities, build it again, test it again, scan it again, go for binary authorization again, and maybe then you are better off, right? So a very strong technical mechanism to make sure that only trusted images are being deployed. Just like VPC service controls we talked about today, it has like kind of a dry run mode, because the same is true. If you enable binary authorization policy, then you can effectively block some images from being deployed, right? And you have your dynamics in the company, you have a roadmap, your developers will say, okay, but we need to have this feature by then, right? So we need to push it no matter the vulnerabilities, right? So there is some dynamics here where you can also first enable some kind of a dry run mode on binary authorization and only then enable the whole thing. Okay, hopefully that's clear. There's a question, can we say if we have gate thresholds in SonarQube, then we can skip. I don't know SonarQube, to be honest, but basically, yes, this is just a proposal, right? And it is also based on some specific open source software, like you have Kritis, you have Signer, right? Basically, binary authorization under the hood, like technically, it's just about checking different things throughout the CI/CD pipeline and then granting or signing those checks with some encryption key. This is what it's about, right? And then an image at the end either has all the signatures. It's just about checking different things throughout the CI/CD pipeline and then granting or signing those checks with some encryption key. This is what it's about. And then granting or signing those checks with some encryption key.
Okay.
there are some alternatives to binary authorization, open source alternatives, just like for all the software, right? So this is something that is branded by Google, like considered a native service. In most services that we cover here, regardless if it's an artifact registry, binary authorization, like anything else, you can probably find some open source software for that as well, right? For the exam, you should stick with Google, at least for the exam, right? Okay, let's have a look at this one. And this actually might scare you a little bit because you have different levels or severity levels of the finding, right? You see some critical, high, you don't necessarily need to know what's the difference, like what the, when one or the other is chosen. But what I will tell you is try to approach that question from a different perspective. Like there are different steps there that need to be executed, and just focus on the order of steps, right? This is my tip for the question. And now I will let you like spend those 2-3 minutes on reading the question. So yeah. Okay, someone says it's scan and build. Remember what we talked about here? We talked about the whole pipeline, right? We said first you have the code, then you do what? You build the code into an artifact. You store the artifact in artifact registry, and only then the artifact is being scanned against vulnerabilities, right? So from that perspective, what is the sequence? It is really built, then you can only scan, right? After you scan for vulnerabilities, you can then check what vulnerabilities were found and how severe they were, right? And then you push, okay? So it's build and scan basically, and then you check for severity. So answer A is actually the only one that keeps that sequence, I would say, right? Okay. So we're done with CI/CD also. Quite an important topic for the exam, to be honest, right? That's why we went through all the services. I wanted you to understand the whole pipeline, so to say, what happens after what's the sequence, because it's pretty important for the whole setup. Let's now switch to something else, securing VMs. So a couple of topics that we need to cover here. The first one is actually the one that we already covered, right, when we talked about GKE clusters, right? Secure or shielded VMs. And 3 options there. Secure boot is one of them, but basically you just need to know all of those 3, and basically also understand that UEFI, right? So if you go to, again, to VMs, and if you want to create an instance, right? Let's go to security once again, and those are our 3 options. Let's go to the documentation again. So please understand the difference between the UEFI, right, and the VDPM. Okay, so there are some tricky questions where both shortcuts, like you might see UEFI and VTPM as the ones. So you need to differentiate. You need to understand that, okay, the one is for secure boot, and secure boot is for this and that. VTPM is for a bit something different, right? So that would be just my final comment regarding the shielded VMs. The next topic for securing your VMs is something called confidential VM, right? So by now you probably know that all your data within Google is encrypted at rest, right? You cannot even turn off that encryption, so that's good. It is also encrypted in transit when it moves through the network, right? That's also nice. What's the third, like, final piece of the puzzle? It is encryption in use, right? So this is pretty interesting thing where it's also encrypted in transit when it moves through the network, right? That's also nice. What's the third, like, final piece of the puzzle? It is encryption in use, right? So this is pretty interesting thing where your data can also be encrypted when it is being processed by a VM, for example, right? So the idea here is, I'm not an expert here, but my understanding is that your data is encrypted in the memory of the VM, right? If it's being managed or processed by a VM, within memory it's still encrypted, and only then when it gets to the CPU, it's actually being worked on, then it's decrypted. encrypted, and then when it's written back to the memory or to disk, obviously it is VM, right? If it's being managed or processed by a VM within memory, it's still encrypted, and only then when it gets to the CPU, it's actually being worked on. Then it's decrypted, and then when it's written back to the memory or to disk, obviously it is encrypted again, right? So kind of a final third step of encryption in use. How do you make it happen in GCP? Well, you just enable a service called confidential VM. You just click enable here, and that's all. Obviously, there are some constraints, right? The whole encryption in use thing is based on hardware platform, right? So it says, well, you need to have AMD Milan or later, right? So I cannot choose Intel-based processors, right? They will not enable it for me. But if I choose an AMD Epic, for example, so I choose N2Ds, then I can say I will enable confidential VM, and then I'm done. Basically, this is where that VM, when processing the data, it will also respect the encryption when the data is in use, right? Obviously, you pay a bit more for that feature. It somehow slows down the processing just a little bit, right? It's like a couple of percent, but it does slow down the processing. But technically speaking, this is everything you need to do. So that's quite surprising, and that's quite nice. You would use that kind of a feature in some special cases mostly, right? It's not where you would like to just enable it for all your VMs across the whole organization. This is something that should be really maybe addressing some compliance requirements, or when the VM is really processing some very, very sensitive data, right? So here it is. Like, you don't need to know all the details about it. You should be okay with what I just told you, right? The next thing about VMs is sole tenant nodes. So again, when you are creating a VM here, well, you don't really care about the hardware, right? You just want your VM. It is yours. You don't share it with any customers. Other customers do not see your VMs, right? That's obvious. But underneath the hood, well, this might be your VM, and those might be VMs of different customers, and they are all running on the same physical hardware within Google dataset, right? And you can ask, well, so what? I would say nothing in most cases. Like, most companies who operate in public cloud are just fine with that approach. They accept it. They have no issues with that, right? But some of the compliance regulations might actually say something like this. Regardless if you're regardless of where you are deploying your VMs, you need to make sure that you have a dedicated hardware of yours for your VM, that you are not sharing hardware with anyone else, right? So this is where you just need to be aware that Google has those sole tenant nodes, which allow you to do exactly that. Again, mostly for compliance. Sometimes for licensing optimization, right? So maybe you have a lot of Windows workloads with CPU-based licenses. So maybe you should just first commit to a VM or to a group of VMs, right? That will be only yours. Google will charge you for those every month the same, regardless if you are using like 5% or 100% of the VM's hardware, like, resources, but you have them for you only, right? So another thing you should be aware of. Now, always login. So we are moving forward again with VMs, but this is rather about how you access your VMs, right? How you SSH and how you RDP into your virtual machine. So you are probably aware that Google gives you a ton of defaults, right? And one of those defaults is to enable you very easily access your VM. So if my VMs were up, right, I could just click that SSH button here. And what would happen is another window would open, and I would be just let in. I could switch to root. I could do anything, right? Google makes it very easy for us to access our VMs, which does not mean that it is a safe or secure or a recommended practice, right? So in other words, you should make it harder for your cloud engineers to access the virtual machines. How do you make it harder? You make it harder by enabling something called OS login. So that's something you might have already learned about. This is actually where you need to first enable it, right? So you can do it on two different levels, right? So you can either go to metadata on your project level, right? So if you go to project metadata, you can say onto my cloud safe or secure. Google makes it very easy for us to access our VMs, which does not mean that it is a safe or secure or a recommended practice, right? So in other words, you should make it harder for your cloud engineers to access the virtual virtual machines. How do you make it harder? You make it harder by enabling something called OS login. So that's something you might have already learned about. This is actually where you need to first enable it, right? So you can do it on two different levels, right? You can either go to metadata on your project level, right? So if you go to project metadata, you can say, I want to inject a key named enable minus OS login, and then I would say true, right? This would like turn on OS login for all the VMs within the project, right? Alternatively, I can go to VMs, right? And when I create a VM for all the VMs within that project, right? Alternatively, I can go to VMs, right? And when I create a VM, I go to security again. And this is where I'm saying I want to control VM access to IAM permissions. Effectively, it's the same. It just enables OS. Right? So you can enable it on the project level or more granular on the VM level. Now, what happens afterwards? First of all, Google checks your permissions, right? Because if you don't enable OS login, just like I said, you click SSH, and well, you need to have some minimal permissions, but they are really like nearly nothing, and you are let in. With OS login, you are checked against IAM, right? So first, IAM checks if you have one of two specific roles. So I also want you to remember those roles because they are quite important. Those are named login, compute OS login, or compute OS admin login, right? So you either are checked against being a user, right? So you will be let in to a VM, but you will not be able to switch to root, right? To administrative user. If you should be an administrator of a VM, you need more privileges. You need that one, right? Compute OS admin login. So this is one of the advantages. OS login, when turned on, it goes through IAM, and it also allows you to be more granular, to grant someone access to SSH, but without admin permissions, and then grant someone access to SSH to a VM with admin permission, right? That's the first thing. And the second thing is this one, right? When you turn on the OS login, you can require two-step verification, right? Remember when we talked about it on our first or second meeting, you can, or every user can define their own 2SV, right? Where did we define it? In cloud identity, right? So here in GCP, you just require it, but the definition, right? What is it about? Should it be a code or an SMS or an authenticator app or something else? This is defined in cloud identity. And then when your employee wants to SSH or RDP into a VM, they are first checked against IAM, right? Against those roles. And also they are checked, or they are required to provide a second verification method, right? So this is like increasing the privileges or the security of users accessing the VM servers, right? So hopefully that's clear, and that makes sense, I would say, okay? Obviously, you also need something else. What else do you need? What privileges do you need to access a VM? What do you think? Remember that a VM is running under a what? What privileges does a VM have? A VM has privileges that the service account has, right? VPN, well, you don't need VPN. Yeah, right? You are maybe IAT, right? It would be a more suitable thing. Service account, exactly. A VM is running as a service account, right? It has privileges of a service account. What happens if I SSH into a VM? Well, I suddenly get the privileges of that service account, right? And just because of that, Google also requires me that when I'm SSHing into a VM, I am checked, or IAM is checking, if I have privileges to use that service account or to impersonate that service account, right? Just because by simply SSHing into a VM, my privileges can be elevated to the privileges of a service account, right? So that's another tricky point there. Okay. Into a VM, my privileges can be elevated to the privileges of a service account, right? So that's another tricky point there. Okay. The last topic I planned for today is OS. Image families. So that's another thing where you might be asked about a couple of things, right? When creating a VM, you are choosing a boot disk. Now, you must have noticed that there are a lot of options here. And for example, Google gives you a ton of options like different operating system types and versions, etc. So you can imagine that you have an organization, right? And there are like 100 or 10,000 VMs within your organization. Now, what happens if everyone is just free to choose whatever operating system and whatever version they want, right? You would end up with a total mess, and you would end up in a situation where it would be hard for you to manage those VMs, to patch those VMs, to make sure that those VMs are updated and secure from different vulnerabilities, right? That would be a nightmare, okay? So this is where Google gives you some choices. There are two levels that you need to be aware of. First level that some customers choose is that they are saying, okay, we are fine with those public images, right? They are really fresh, like Google is updating those images very often, so they are really up to date. So some customers are saying, I am fine with public images, but I don't want my users to choose just anything. But maybe my business decision is to just use, I don't know, Ubuntu, right? Or Ubuntu or Debian or something else, right? So you can implement an organization policy constraint, obviously, right? That will limit the choice, that your users will be only able to choose some of those public images. That's first level of security, okay? That you are able to control the VMs better by having only VMs with Debian or Fedora or something like that. The second level, it's more ambitious, but this is what you should be aware of, is to enforce that your users are not able to use public images at all, right? So what happens then when they need to create a VM? Well, they are only allowed to create a VM with a custom image. So this is where you first need to do some work. What work do you need to do? First, you need to create a separate project or a set of projects in GCP, just like you will centralize with different things within GCP. The same goes with those images. You create a separate project, and then someone is responsible for baking those images within that project, right? Maybe they would take a public image, they would harden it, they would increase the security, they will remove some options, add some security settings, etc. And they will present those images. And then me, as a consumer, I am here in my project and I want to create a VM, I would first need to point to a project where those images are centrally managed, and only then I would choose an image out of those images that I am allowed to use, right? So that's a more advanced option. This is a more secure one. This requires you to first centralize, right, to bake those images. It requires you to know a couple of stuff, and please follow those links for the exam, because if we have just said that you will be baking those images, then you have to version them, right? You have to deprecate the old images, then you make them obsolete, then you delete those, right? So how do you, right? For secure one, this requires you to first centralize, right, to bake those images. It requires you to know a caption on and allow. So some customers are saying is updating those images very often, so they are really up to date. So some customers are saying, I am fine with public images, but I don't want my users to choose just anything. But maybe my business decision is to just use, I don't know, Ubuntu, right? Or Ubuntu or Debian or something else, right? So you can implement an organization policy constraint, obviously, right? That will limit the choice, that your users will be only able to choose some of those public images. That's first level of security. Okay, that you are able to control the VMs better by having only VMs with Debian or Fedora or something like that. The second level, it's more ambitious, but this is what you should be aware of, is to enforce that your users are not able to use public images at all, right? So what happens then when they need to create a VM? Well, they are only allowed to create a VM with a custom image. So this is where you first need to do some work. What work do you need to do? First, you need to create a separate project or a set of projects in GCP, just like you will centralize with different things within GCP. The same goes with those images. You create a separate project, and then someone is responsible for baking those images within that project, right? Maybe they would take a public image, they would harden it, they would increase the security, they will remove some options, add some security settings, etc. And they will present those images. And then me, as a consumer, I am here in my project and I want to create a VM, I would first need to point to a project where those images are centrally managed, and only then I would choose an image out of those images that I am allowed to use, right? So that's a more advanced option. This is a more secure one. This requires you to first centralize, right, to bake those images. It requires you to know a couple of stuff, and please follow those links for the exam, because if we have just said that you will be baking those images, then you have to version them, right? You have to deprecate the old images, then you make them obsolete, then you delete those, right? So how do you have to know what does it mean, right? For your end users, maybe they get a warning, hey, you are not using an up-to-date image, but maybe then they can't even use that image because this is outdated. They need to use a newer one, for example, right? That's one thing. Exactly, just like shared VPC. So basically, a centralization approach to managing your image, right? Second of all, trusted image policies. So this is where you decide, right? This is where you make a decision. So have a look at the policies, just because first you need to decide if your users can use any images, or maybe they can use only some of those public images, or maybe, just like we said, they cannot use any public images, but they need to use your own custom image, right? If you have just centralized, right? So if you have a central project for your images, and then all the other projects can just use those images from that central project, well, you need to also understand how it plays out when it comes to IA, right? Because now I am here in my project, and I am now using images from a different project, meaning I need to have some privileges, right? So there is some kind of a IAM-related setup that you need to do in order to make it happen, to have that central project, like share images with all the other projects, right? And finally, there are some best practices when it comes to image families. So I don't want to you to spend like hours on that. It's definitely not about it. But if you like spend 30 minutes on understanding all of those links there, you should be more than good when it comes to managing your own custom images, right? So that would be good. And maybe since we have 1 or 2 minutes there, let's have a look at one of the questions. So the company wants to receive immediate alerts if they're having changes to the boot sequence, right? So immediately you should think about what? About shielded VMs, okay? If that's shielded VMs, what do you think? Which ones do we eliminate? Which are still possible? Okay, we have the first answer, so someone is pretty certain. I would suggest to start from eliminating. Like, if that's about shielded VMs, probably we could eliminate the second answer, right? You know, big cloud logging, it wouldn't be enough, right? Then we are left with policies only. That makes sense, right? Because you would make a policy for the shielded VMs. Now, do you define that policy on an org level or project level? Well, probably org level is better, right? So just by elimination strategy, we have just eliminated B and D. So exactly, we are between A and C. And this is where you just need to know. It's either UEFI or VTPM. So this is why I told you policies only. That makes sense, right? Because you know, big cloud logging. I would suggest to start from eliminating. Like, if that's about shielded VMs, probably we could eliminate the second answer, right? You know, big cloud logging, it wouldn't be enough, right? Then we are left with policies only. That makes sense, right? Because you would make a policy for the shielded VMs. Now, do you define the policy on an org level or project level? Well, probably org level is better, right? So just by elimination strategy, we have just eliminated B and D. So exactly, we are between A and C. And this is where you just need to know. It's either UEFI or VTPM. So this is why I told you, please follow the documentation. And this is where you just need to know. It's either UEFI or VTPM. So this is why I told you, please follow the documentation for shielded VMs, differentiate between those, and based on that, you would be able to answer that kind of question. The answer that we just got at the very beginning was the correct one. So yeah, with that, let's wrap up for today. Thank you for the session. It was a nice one from my perspective. Let's meet each other next week. Yeah, take care. Thank you.
Thank you, Maciej. Thank you, everyone. See you in the next one. Bye.